In this section, I'm going to go over some of the inputs to some of the data forms. Now, some of them are really simple. For example, I'll look at lighting really quick and show you what I mean by simple. You know, what is the lamp wattage? What's the ballast wattage? I'm not going to go over the simple inputs. I'm only going to go over the ones that are cryptic. In general, though, if you don't know an input, you can always press Shift F1 on your keyboard. You click on the input, Shift F1, and that should tell you what is supposed to go in that field. But let's go over them anyway. And before I do, I want to tell you that along with these lessons, we've made available some Microsoft Word docs, and one of them is called Selective Data Form Reference. Now that I would suggest that you open that up and use that to take notes with. It's important you take notes because what I'm going to cover you may forget. I'm going to cover a lot of information, and it would really probably be best if it was written down. Okay, in the project form, under customer, this, the company name, that actually shows up on some of your reports. So that's one thing you might want to make sure you do enter what you want that to be called. Also under status, these milestone dates, there is a bug in the program, and in the reports they have a date in there, and you would think that the report delivered or maybe audit completed would be the date that you want that should be in the report. I don't remember, I'm sorry to say, which one it was, but I think the solution would be just to fill in all of them to be the same. Let me see if I can find out what exactly I'm talking about. So let's see if I did an engineering cost report. Let's see if there's a date in there. Okay, see, there's template church. I told you that part. And then if we look at a date, September 30th, 1993. Let's look at it again. So if we go in here, the project, status, let's make these all different, okay? So we'll make this September 1st, we'll make this September 20th, and we'll make that the 30th. Okay, and I'll save this. File, save as. Yeah, sure. Okay, and we'll simulate it real quick. And now run a report again. So energy cost. So if you look down here, it says September 1st. So the date that you're going to see in your reports is going to be the date that says project start. That's the bug. You would think it would be report delivered. It's not. Okay, so that's the point of looking at this form. In the building form, first off, when you see this building height and number of stories, you might think, hey, that's redundant. I already put that in the zone form. Well, that's right. If you look at the zone forms, they do have number of stories, and they have, well, a floor to ceiling height. Those are really a little different. They're talking about number of stories within the zone, and this one is talking about stories in the building. The reason these are here is they're also used with what's in this air infill, which means infiltration form. You might remember from doing ASHRAE loads when you were in college, if you had to do them by hand like we did, that those were two of the inputs, along with the terrain type and the wind exposure. You would be able to put those into some tables, or there's tables in ASHRAE fundamentals, and then it would calculate the infiltration, and that's what these numbers are down here. Okay, so those are calculated based on those ASHRAE tables. Now there's another way to do infiltration as well. That's this design AI. So AI stands for air infiltration. And notice if I click on that, I have the 0.4s and 0.2s. Okay, so where did those come from? Well, if you do it this way, these inputs don't do anything. Here, I'll change this and you'll see. See, they don't do anything. And nor would these do anything either. So the design AIs are from your zones. In your zones, we have design air infiltration. So you can go either way. If you choose to let the program calculate infiltration, That's one way. Or if you want to type them in yourself, if you know what the design infiltration is, then you would select yes for this. There's actually a little more to air infiltration, and I believe I'll be covering that a little bit later, but I'm going to say no for now. These are some checksums. You can use this to figure out, your watts per square foot, and a few other things like that. It's of some use. Also, sometimes I use this is a degree day generator, and it'll tell you the number of degree days based on different balance points. In the economics form, the main thing to mention is these marginal rates are not used at all. It doesn't matter what you put in there. The way that I'm going to show you to use Market Manager, it's not used in the least. The escalation factors are used. They're used in life cycle costs and some of the other economic analysis. In the weather form, this is design data, design month. Now, let's go to bin hours. Some people will look at this and they'll think, hey, Market Manager is a bin data program. It's not. It's not a bin data program. If you do want to put in other weather locations, or if you want to put in last year's data, then you might choose to type it in here. And this is where you would type in your bin data. And you would think, oh my gosh, this is going to take forever. It doesn't. Actually, I've done it a few times. It might take 10 or 15 minutes to type in all those numbers. It's not that bad. Finally, there's the user. This is just where you put information about yourself. All right, now let's get into the harder forms. The plant form. Okay, first off, these are your auto resize buttons. Okay, if you don't know, let's say the outside air percentage, you don't know, this is the minimum outside air. Let's just say you didn't get a chance to look at the air handlers and you don't know how much they close, or you were on the roof and you looked at the units but they're at 100% outside air at the time, then you would have that checked and let the program calculate what it thinks the outside air minimum should be. We all know that in real life the equipment rarely operates the way it should, but you got to guess something, and this program would then guess it. It also can calculate what the fan CFM should be, what the cooling capacity should be, the heating capacity, and then HP is not horsepower, it's heat pumps. It's not Hewlett-Packard either. Okay, here under design, these are the sizes that Market Manager thinks the cooling capacity should be, and this is just converted into tons. So these are the same number really, and then that's heating as well. The load floor, this is not where you put the size of the cooling equipment. It's a common beginner's mistake, and it's a big mistake. The load floor is how much cooling gets wasted when the chillers are on. For example, let's say you had leaking valves, and whenever the chillers run, that the valves are always open. They don't shut all the way, and so this would represent how much energy gets wasted whenever the chillers are on. This could also represent steam trap losses as well. Okay. Usually in most models these are empty, even though there really are leaking valves. I think the way people maybe make up for it is when they calibrate, they may be changing their COPs or their efficiency. In the cooling form, this is where the subform, this is where we would put in a chill water reset or a condenser water reset. Now here it won't allow me the option to do that, and that's because there is no chiller. But if you did have chillers attached to this program, or I'm sorry, attached to this plant, then it would allow you to enter in chill water or condenser water resets. Down here is your cooling lockout. Negative 30 degrees means that if it's below negative 30 degrees, then cooling may be locked out. In other words, it's always operational. It doesn't mean the chillers will run when it's negative 20 degrees. It means that if there's a call for cooling, then the chillers will run at negative 30 degrees. And a heating lockout is down here. Here's a hot water reset for the boiler. Set point, max reset. Well, no, there is no reset, but you could set one if you wanted to. So if I wanted to, I could have a hot water reset. And there's a heating lockout. So this means that if the outside air temperature is, let's say, 75 degrees, even if there is a call for heating, there will be none because the boiler is locked out. Okay, that's the plant form. The system form. The most important one is this type. Now the type is what type of air handler you have, pretty much, or actually even better, how do you get the heating and cooling energy from your chiller and boilers or TX units and furnaces to the zone. So the system isn't necessarily an air handler, it's just the means of conveying the heating and cooling energy to the zone. And these are some of the different types. Now if you don't know what some of these mean, and it's fine if you don't know, because only a Market Manager user would know some of these. Let's say VTCV. Well, what is that? You can do Shift F1 and there's a really good explanation of what these different units mean. So VTCV, and then here's an explanation. And basically a VTCV is a single zone system. Okay. In the Market Manager cookbook, it goes over these zones actually, or I'm sorry, these different system types. Now when you change a system type, let's say we change this to a terminal reheat system, it will change the system family and the supply air control as well. These two I would suggest you do not mess with, ever. Maybe supply air control in extreme cases, but system family, do not mess with these. If you do, you can end up with a custom system. And if you have a custom system, I'm not sure how Market Manager is going to work. You got to remember when you're using a program that a programmer wrote this, and they wrote this assuming that you would make reasonable inputs. And they do make programs, or they do program it so that you could make some unreasonable assumptions, but I'm not convinced that they have considered every combination of unreasonable input. And for that reason, I would suggest you try to avoid custom systems whenever possible. Okay, so back to these systems. If you choose a system, it will change the manual defaults and it may create a fan or two. Okay, you do want to let it change the defaults because that's going to change these things. Okay, let's go to scheduling. HVAC schedule. I wouldn't call this HVAC schedule. I would call this HVAC schedule definitions. What's the definition of a day? What's the definition of a weekday? What's the definition of summer? And that's what these are. And down below is where these definitions are actually used. So for example, if we thought it was on during the day only, in summer, during weekdays, we defined weekday, we defined day, and we defined summer. Okay? Now the program, this is a fast way of scheduling. If you wanted to schedule it your own way, that's a little more, let's say, specific. Let's say every Thursday the building was closed, then you can click on custom schedules and it will add schedules for you. And then in the schedule you can type in what you want. So let's say Thursdays they're closed. Let's just make it simple, only in the summer. So I uncheck Thursday, and then I'm going to drag this up to add another one. I'll call this one Thursday. And then I would make this be just Thursdays. Okay, and then to make it closed, I'll just type in zeros. Now to get through this, it doesn't necessarily work. I'm recording my keystrokes and they don't work as well. Some keys don't work well when I'm recording, but the fast way to get through these schedules is to press 0, then tab, 0, tab, 0, tab, and that will get you through very quickly. Okay, back to the system form. So we've talked about that. The operating modes, I would really call that HVAC schedule. So in your notes you would type in, you'd write in HVAC schedule, not operating modes. Here you'd write in HVAC schedule definitions. Okay, HVAC standby. This is an ASHRAE term. What it means is that if you had, let's say, a system that was on day only, Okay, and you put it on HVAC standby for heating. What that means is that the unit will operate only during the day, but at nighttime, when it's supposed to be off, it will cycle on and off to meet set point. Now, this is necessary in some places in the Midwest and the East where it's cold. You might want to turn your HVAC off and you might want to do a setback, but you want your HVAC to cycle on and off to meet a set point. Because if you just turned it off, then the pipes might freeze. It might get too cold in your zone. You might have a night setback, and then you can cycle the fans on and off to meet your night setback. That's what they mean by HVAC standby. And then there's a cooling HVAC standby, be the same. It's just for cooling. Okay, the outside air subform. This is where you deal with the economizer. Do you have one or not? And then there is a winter night shutoff. That would be, suppose you have an economizer, but maybe on weekends, on winter nights, we want 0% outside air, even though my minimum is higher. Okay, here's a case where my minimum was being auto-sized. Let me go back to that auto-sizing. If I choose not to auto-size outside air, then I can go back to my system and I can type in whatever outside air minimum I wanted. Okay. Preheat coil. I'm just going to I'll go over all of them. Do you want infiltration in your loads or not? Well, my gut reaction would be yes, of course. Well, that's not actually always the right thing. If you've got a positively pressured building, which you would usually have in central systems, then you have no infiltration. Actually, you have exfiltration. In that case, you don't want infiltration in your loads. So you want infiltration in your loads when you have zonal systems. That might be a package unit on the window and that's all that's heating. Or maybe you just have a hydronic system that with boilers, not boilers, I'm sorry, with radiators by the windows. That would be a case where you might have a negatively pressured building and then you might have infiltration. The defaults for this program are such that the zonal systems have air infiltration in loads checked. The central systems have it unchecked. Outside air damper seals doesn't really do anything. It just gives you a warning message. It's not of any value. The custom outside air schedules allows you to type in, lets you vary the outside air. Here, I just added some. So you can have different amounts of outside air at different times of the day and month. And that's actually a good control strategy that I used to employ when I was working in a hospital. In the detail form, this is where you put the cold deck temperature, or the temperature that comes after the cooling coil. So here I have 55 degrees, which is pretty typical, and then the temperature after the heating coil, and 110 again is typical. If you want to type in your own temperature, you'll see, and it's different. You'll see it's. I thought, yeah, it would be italic because 110 is the default, which is a reasonable assumption. What this is what they call a wet bulb depression. It means that if the cold deck, the temperature coming off the cold deck or off the cooling coil is 55, what is the wet bulb temperature? And if you say 55 minus 5, that would be 50. So this is assuming that the wet bulb would be 50 coming off the cooling coil. If you want it to be fully saturated and it to be 55 wet bulb as well, then you might put in a 0. This is the cold deck reset if you wanted to reset the cold deck, and this would be a hot deck reset. And I think that's all I want to talk about here. For loads, the program breaks out loads by different components, as you can see. So if I went and changed the walls, you'll see this will immediately change. These calculations are done immediately. What's interesting about this is it'll calculate the total loads. Then you have equipment, your air handler, which will add fan heat and which will add some system ventilation, which is the outside air. And then you get the total load that the actual air handler or the cooling coil has to meet.